Afternoon again, everyone, and welcome back. Just give a nod, can someone hear me okay? Just make sure the audio hasn't changed while we've been on break. Hear me okay?
You're fine.
Cool,
All good.
awesome. Cool, so welcome back, everyone. Obviously, one stage of 3 down for kind of this afternoon's lecture. I'm shortly going to introduce our kind of next speaker. But just the kind of context around when we were shaping up this day, got earlier in the year, and been at Mercedes-Benz World, we really wanted to get the theme of kind of speed out there, and hence the DOCSIS 4.0 kind of conversation just. And then we also kind of reached out and kind of looking in, one of the absolute key drivers and key speed champions out there is obviously fiber. So next speaker, really exciting to kind of introduce, is Craig McMillan from Sienna. He's going to take us through a kind of presentation, obviously more focused on the world of fiber, some really interesting stuff around the backhaul and considerations around that. I've got a short intro for Craig, so I'm just going to run through that in a moment, and then I'll hand straight into you, Craig. Obviously from a Q&A point of view, same goes again. Please submit your questions as we're going through. I'll kind of confirm those as we go, and I'll queue them up, and I will give them all to Craig at the end of his presentation. You probably caught the tail end of the questioning with Mark on the speaker before. I blame the audience, not me.
I'm worried about the questions already, James.
That's fine. There's a challenge to the audience, right? Get thinking caps on. So quick introduction then from Craig, and I'll let you introduce obviously what you're going to speak through, and if you want to add any more into this. But so Craig McMillan, he's the lead EMEA engineering team, responsible for facilitating the introduction of Siena's packet optical technology, software and services into communication service providers, and global content networks throughout the EMEA region. Craig's worked at Sienna for 22 years. And you call Southeast London home?
I do.
Cool. So over to you. If there's anything else you want to add to that before you drop into your presentation, the floor is yours.
No, thank you, James. Let me just share the start of my presentation. Can you see that okay?
Can indeed, and I can hear you fine, so the floor is yours.
All right, great. No, thank you, James, and thank you very much for the SCTE for the opportunity to talk today. Yeah, as James was saying, I've been working for Sienna for 22 years now, and predominantly working with large service providers. And when we're talking about fiber and speed, the progress that I've seen in those 22 years is absolutely amazing. In my time in the telecoms industry. I'm sure you're very used to, with the audience normally hearing more around the access and age part of the network. Well, today I'm going to kind of reverse that a little bit and talk about technologies that are really a lot in the core, but they are heading out more into the metro and access, and that's really around coherent optics and how we're driving more capacity within inside the network. So to talk about fiber, I'm going to be here to talk about fiber and speed, but also about how today's networks need to adapt. So let's kick off. So as I've seen, the network has never been as important, especially with COVID, and really important to helping to connect people and things together. We've seen hopefully now and post-COVID that the future is going to be a whole lot more digital. Things like video streaming, working from home, it's all become more popular with, savings and facilities for companies, schooling from home. I mean, all of us have been there trying to, support our kids during the last year and a half when they've been schooling from home. The reduction in business travel, that's a major expectation, in the reduction in the travel and hotel costs. And what does that then lead to? That really leads to then, increased bandwidth requirements, especially around things like Zoom and Skype and WebEx. All those tools really require that symmetrical bandwidth requirements that we need in the network. And also finally, the gaming industry, it's taken off massively. So all these, so the network of the future really need to be able to adapt to this kind of changing long-term impacts that we see And I'm just going to delve into that into a little bit more detail, especially, you know, around where our homes and, you know, our homes have become the kind of new branch office, let's call it, you know, where it's really been the focal point of where we kind of learn, play, and work. You know, as the internet took off back in the 1990s, you know, residential connectivity, you know, a 5 meg connection was perfectly satisfactory for, you know, whatever kind of web browsing we did, surfing the web, emails, kind of low resolution video and images, and even just like text chatting. But now, if we look at it now, like so much has changed since then, including the pandemic, which has really changed things. How, you know, forcing most of us indoors, and the network has been our kind of lifeline, let's call it, to the outside world. You know, to keep us entertained, you know, as I've mentioned before, we've had that, you know, high definition video streaming. We've been playing immersive games with AR and VR have come along, are still really, you know, haven't really taken off massively, but they're increasingly going. To keep us in shape, you know, we've been getting on the connected treadmills or the connected bikes, you know, with video streaming, again, high definition video to the instructors that we have. Keep us healthy, you know, having our doctor's appointments online as well. But also critical, as I mentioned before, it's really the homeschooling for the kids to continue their education as much as possible by attending virtual classrooms with their kind of classmates and teachers. But even for all of us on the go, and this is a classic example when we'd rather be, you know, somewhere else, maybe today, enjoying looking at fast cars, you know, we're all sitting on Zoom, you know, continuing to work and pay the bills and, you know, keep the economy afloat. But a lot of these things, once the pandemic even resides, which hopefully touch wood will be soon, you know, a lot of this will still remain after. You know, we'll need, you know, we'll be still doing a lot of the work and playing and learning from home, where, you know, we need that kind of high speed, low latency connectivity with the kind of carrier grade availability and security, you know, with a minimum 100 meg connectivity. So it means that, you know, the CSPs that will be successful in this kind of residential broadband services market, they must really, you know, look to modernize their networks to proactively kind of address these kind of this unstoppable trends that we're seeing. So what, to achieve these kind of three, this kind of network experience that we're looking for, there's three key areas that I'm going to touch on today. First of all, obviously, you know, the one that I'm going to maybe focus on later in the presentation is really the more bandwidth that we need coming into our houses. Closer is really, you know, how do you keep for those certain applications, how do we keep the low latency requirements, meet the low latency requirements as much as possible? And then smarter, you know, how do we make the networks that we have out there a whole lot smarter, self-optimizing and self-healing? But first of all, let's look at faster. So a bit of an analogy here. So if we compare the speed of cars that we all wish we were at the Brooklands Museum today, it would have been, you know, back in the 1980s, the fastest car that we had was approximately 201 miles per hour. Sorry, I haven't done the kilometers per hour comparison. But if we now go to modern day, we've got this Koenigsegg, I'm not sure I'm even pronouncing that correctly, Jesco Absolute, which apparently can do 330 miles per hour. You know, if you look at that, that's a 65% increase in speed over over 40 years. Now, if we compare that to the telecom industry and where we are in the network speed acceleration that we're seeing, you know, this is the kind of what we're seeing, the specifications around Ethernet standards versus the speed on the optical fiber links. You can see back in the 80s, we had the 10 meg was a standard, and then if we move to modern day, you know, we've got 400 gig E connectivity in the routers out in the network. That's a 40,000 times faster. Now, if we look back at our car comparison, that means our modern day car should be able to go 8 million miles per hour. or a trip to the moon would be less than a couple of minutes. But as you can see from the graph, the first 6 Ethernet rates had changed over the first 35 years. That was moving from a 10 meg connection up to 100 gig E ratified and a 40 gig E in 2010. But now over the last few years, we've had another 6 data rates right up the way to ratification of the 400 gig E interface. So it just shows you the rate of acceleration that we're seeing on our networks at the moment. But it doesn't end there. We are looking, and you can see the two in, I don't know if hopefully you can see the two in the white circles here, that there will be a push to get to that 1.6 terabit and 800 gig E as well, and not in the too distant future. And it's all relative to the improvement in the size of the silicon that's used. So if we look at the kind of new applications that we've got, connected cars, industry IoT, telemedicine, AR and VR, but how are these, applications enabled? With the hope of, 5G providing mobile connectivity up to about 10 gig, while we're hoping then that the optical, the wireline and the optical connections will be able to deliver a magnitude higher than that. But combining these wireless and wireline technologies provides connectivity for these applications. Some of the examples here are shown in blue, with connection speeds indicated on the vertical y-axis. To deliver upon the kind of low latency requirements of these applications means moving the processing and the content much closer to the edge, where it's both created and consumed. This means physically moving centralized cloud data centers assets closer to the end users, both humans and machines. And these interconnected assets are called the edge cloud. You can see from the 20 milliseconds, I don't know if you know, if you're using a VR helmet, you need that, you need the round trip to delay to be below the 20 milliseconds when you're using VR, or else you're starting feeling dizzy and not particularly well. But as you can see, show the 20 seconds shown in the middle of the horizontal x-axis. Anything below that 20 milliseconds round trip delay to the end user or machine or application must use the kind of edge cloud. Anything higher than that 20 millisecond round trip delay can use a traditional cloud and more refined just as the cloud infrastructure. Higher speeds that we've talked about, previously, enable some new applications or enhance the existing ones. Very similar, what we've already talked about, like video streaming. But new low latency applications require edge cloud, which affects mobile, enterprise, and residential users, their applications and use cases. Although the connections can be wired or wireless to address the application's high-speed requirements, low latency requires cloud assets to move closer to the edge. So as you can see, I'm going to now look, kind of talk you through what we have and the evolution of the kind of traditional network, to bring that, that closer experience, one of the 3 major assets for the evolved network. So this is kind of what we see as a kind of traditional network out there, 3 separate networks. They're each built independently for residential, enterprise, or mobile, different layers of aggregation as they come back into the major part of the network, and as you can see, there's different operational teams even covering each part. So, it's a complicated network, and it really doesn't deliver the kind of round trip delay times that we're experiencing for some of the applications. The reasons for that is, it does input a lot of these OAOs or regeneration points within inside the networks, which introduces buffers and really opportunities for delay. To bring that better, first way to kind of improve that better cloud experience is really covered by 3 changes that we see in this network diagram. First of all, we see the residential access, enterprise, and mobile is all converged into a universal aggregation. This means that can be the universal aggregation can be streamlined with its access back into the cloud. Second part is really the cloud. Now, the cloud is not just in the core part of the network, but it's brought out more into the metro. And then once you've got this cloud infrastructure that's expanding, you know, it's distributed. It's not just in the core part of the network. It's moving further out into the metro. You know, you then build a dedicated network or DCI or data center interconnect network to connect it together with kind of lowest latency and highest performance network in between them. And that really means that you get to be just that kind of mean time to the cloud. And as you can see, even with this simple change, you can reduce the mean or the round trip delay, you know, by half. Now, then moving on to the kind of fully evolved network, the cloud now has moved right to the edge. You know, the universal aggregation point has also got the routing function built in. So this means it can connect and route traffic correctly to different parts of the network and different parts of the cloud infrastructure, you know, to make sure that those applications that need the most latency or the most latency sensitive really hit the cloud as early as possible. Also with inside this architecture, you know, we've got the converged metro where we're combining the optical and IP layers together into single devices. With these changes, the network, the distributed applications are hosted in different parts of the network to ensure they meet the correct levels of latency that they expect. You know, we're seeing this a lot. You'll see this a lot with a lot of major service providers, you know, that have got these relationships now with cloud providers, where the cloud providers are hosting right out at the edge of the service provider's network. And we're seeing it more and more. But you can see also now that the cloud providers are building their own, you know, DCI networks, expanding away from just the data center in the core, further out into the network. And another key part of this kind of evolved network architecture is the information and telemetry it provides from this kind of underlying programmable infrastructure. You know, we need to get this telemetry and information out of the network to make sure that we can correctly automate it and make the network smarter. And that's when I'm now going to go on to my third area. So how do you make the network smarter? Well, there's different ways. First of all, let's look at AI and what insights you can be brought. You know, how can AI help support and look at where is the best part of your network to build? You know, is the latency too high for a certain application in this part of the network? Well, AI can give you the analysis there to do that, you know, give you that insight to say, oh, you have to change something within inside your network. So it's like, you know, bringing that edge data center closer. You know, how can you use those AI sites then to plan to build and without any kind of manual intervention? Similar with zero touch provisioning or you know, orders to service. How can you rule? Everybody's used to the kind of Amazon way of doing things. I want something tomorrow when I've ordered it today. You know, how can we get that turn up time or order to service as low as possible? You know, things like with zero touch provisioning, where it's very little manual intervention, you can turn up different parts of the network very quickly to make sure you're delivering that kind of network or device or service for the customer as quickly as possible. And then finally, the last part of this is really the analytics piece of the network, you know, and the trouble to resolve. How can you resolve trouble tickets within inside your network? And this is not only, you know, this is obviously moving from a kind of reactive to a proactive methodology, where you're using large data analysis of your network and trending analysis within inside your network to really look at, you know, predict faults before they happen and go and do corrective action. So, you know, it doesn't impact your network or you don't have an outage within inside your network. So that's you know, if you cover these three areas, then it's key then, you know, to deliver that great customer experience, the kind of productivity from your teams, the quality of network that you're expecting, the efficiency and the value, maximizing the value across your infrastructure. But also the main part of this is also really making sure you have a really in-depth knowledge of your network, making sure, and that's kind of back to your inventory, and knowing exactly what you have out there, whether it's a physical or virtual environment, what services you have, where are the flows, what are the users. You've got to have that great set of data there to make sure that you can really do kind of any intelligence and automation on your network. So then, so what if we then look at how this, what we would call the adaptive network, and how you use that to, become that, give that smarter, evolved network that you have out there. You've got that programmable infrastructure. The key part of that, and that underlying infrastructure, is to make sure that's an intelligent, programmable, with open APIs, and streaming telemetry. Once you've got both of those items, you can then look at how you work around to the kind of sense or the analytics and intelligence piece here. You collect the data, you've got someone, you store it, you analyze it, but then you can have an intent-based policies around, okay, what am I meant to be doing now? Or I've seen this issue, what do I need to, or I need more bandwidth. How do you turn up a new wavelength, or how do you increase the baud rate of a certain wavelength that I've already got in the network? And that's where the kind of software control and automation piece, and the kind of, okay, now I've seen what I need to do. I need to go push this. I need to push this instruction down to the network, to really tell the network to go off and do this kind of upgrade or change to improve the experience. So that's where we're really looking at how the network has to adapt. And we've seen during COVID, that all networks have had to adapt and change because of the traffic flows. So that's where really it's then driving towards a kind of self-configuring, self-optimizing, self-healing network as best as possible. And then once you've kind of got this evolved network, well, you can really deliver any kind of, the personalized service for your end user that you would like. It'll be a ubiquitous network delivering whatever type of cloud you have there, private, public, or hybrid. You'll have enterprise data centers connectivity in there, but also, that'll be delivering your Ethernet internet connectivity, but also your IP and MPLS core network as well. And that then gives you, once you've got that kind of built as a converged platform, as a network, then you can really then deliver whatever type of service you want, whether it's a content delivery network for education, point of sale for retail, smart cities or IoT for the government. You've got the basic building block of a network to be able to deliver all these kind of personalized services all around that kind of closer and smarter piece. And then, if we delve into that a little bit more detail around, 5 different areas, that design, at the moment, we do a lot of design, which is kind of off network. You take a snapshot, then you do some manual view or analysis of the network. What we're really looking for is to, how does the network give us insights about how we need to expand the network or upgrade the network or change the network, really to match whatever the market is requiring that we're seeing out there. Inventory and configuration. I mean, I touched on this previously. It's really about, you really need that great details and accurate details, around what's happening within inside your network, or else you won't be able to do any kind of automation. If you have rubbish in around your inventory coming in or configuration coming in, then you're going to get rubbish out. You're not going to really get what you really wanted from automation, and because you need that accuracy around your inventory and configurations, whether it's a virtual or even physical environment that you have out there. So you've got virtual network functions, everything needs to be tied together to be able to do that correct amount of automation. Provisioning, we really want things turned up quickly, real time, maybe multi-carrier. There shouldn't be why you can't go from one area to the next, or one service provider to the next, and not be able to do, have that same service velocity that you're expecting. And again, whether it's a physical or a virtual device that you have as the demarc. assurance, I touched on it before, more reactive than proactive, and using that predictive analysis on your network to have the, that faster trouble to resolve, to make sure you can fix the network as quickly as possible. And then security, all these, security is one of the key, again, looking to see, how your networks can be continually monitored, whether you put some automatic probing inside your network as well to look for security issues, but it's really to build that trust for your end user as well. So then if we look at some of the kind of market dynamics that we saw, that we saw during COVID, surge and massive amount of surge, if we go from the kind of left to right here, massive amount of surge in traffic. Enterprise turned down because they weren't being used, or the traffic to the enterprise wasn't as much as we all gone to the residential, focus on metro and access, symmetrical traffic, as I talked about from the video calls, web scale, their amount of traffic went off the chart, and we all saw those graphs about the consumption of traffic during COVID. But their networks were able to survive it, and that was the great thing. Web scale again, or wholesale again, big surge of traffic. Networks grew hotter, but again, they had to add some additional capacity, but not what their networks were very well scaled to achieve it. Fortune 100, well, we all now work from home, that's going to be something that's moving in the future, and then 5G. But as I say, which one of the ones that we see as kind of the lasting changes throughout the networks? I think from the whole part of this point of my presentation, you can see it's really the focus on that metro and access. How that metro and access is going to scale. Not all the traffic, as it said, is going to route back into the core part of your network. A lot of it's going to be dealt out near the edge because of the different types of application, and with 5G coming along as well. But also that more symmetrical traffic, as I say, all the video calls that we do nowadays from home really changes its kind of dynamic. Collect that traffic earlier, get it onto the cloud or the DCI network as quickly as possible. So it again achieves the kind of lowest latency. It doesn't need to be routed or switched. It just needs to be delivered exactly to the correct part of the DCI network. Traffic patterns are changing. We're seeing, as I said, traffic patterns are, not for the enterprise, are a whole lot different now, because what is the change in the traffic back into the residential? So we're seeing traffic changes continually. Fortune 1000, well, that hasn't, as I say, we're all, at the moment, all of us are probably all sitting on VPNs. How do you secure the best kind of working environment for your staff at home and for your customers at home as well? And then finally, looking at the 5G part of it, the existing China dynamics that we have going on inside our industry, but also private 5G and how it's progressing as well. So, that was kind of what you're looking at 3 different areas. The smarter, closer, and faster. So now, I'm really going to spend the kind of second half of the presentation looking at really focusing on speed. And Sienna, we are out there as one of the leading vendor for speed, let's say. So let's get into some of the details. So again, it's really really addressing the massive amount of scale that we need inside our network, and that's what's really going to be driving what we would call around coherent technology. This is the ability to deliver high capacity wavelengths across a DWDM system. So more and more network operators are really looking at coherent technology to to solve the problems that they have with inside their business challenges. Network capacity, I've talked about that already. Massive growth inside our networks, which doesn't seem to be stopping at any time soon. But really what they want to do is that reduction in the cost per bit. How can the new generations of coherent technology deliver that better cost reduction and competitiveness, really around, being able to turn up services quickly, get the latest technology, drive it as quickly as they can, and that really means that they're increasing their competitiveness in the market. But this is perceived, this coherent technology is across all different parts of the applications, whether it's submarine from 10,000 kilometer links across the Pacific or Atlantic oceans, or right the way down to like intra DC net connectivity. And never mind, something for this kind of audience is around the whole lot more fiber access, whether it's fiber deep or 5G. All these different areas are really looking at how coherent technology can help with their business challenges. So what are some of the factors influence and design of coherent optical solutions? Well, as I said, the first one is really the equivalent 100 gig port capacity. Is experienced still double-digit growth year on year, and as I say, no signs of that slowing down anytime soon. But also, you're really looking to do more with less. You're looking at how we can get this use same kind of hardware and technology, but deliver those higher capacity wavelengths. So you can see from the graph on the side, going back to 2005, right the way through now 2021, where we've gone from 10 gig right the way through now to the 800 gig is what the latest and greatest vendors can supply as a single wavelength onto your network. And the relative, obviously the capacity of that's growing, but the kind of net cost of that is kind of remain constant throughout that life cycle. So you can really see how it's reducing the cost per bit. The other part is really around coherent technology is really the dependency on software and automation. Delivering 800 wavelengths or 750 gig wavelengths or 600 gig wavelengths really isn't that easy onto a network, and it's gone beyond manual provisioning. You really need dependency on software and automation to really make sure your network evolves. The correct planning tools that really understand how you utilize, get the best out of your network is really required. And then the final one of the main factors is really, the drive towards 400 gig E, and really the drive towards 400 gig E everywhere. That's one of the main reasons where we look at how we drive those 800 gig wavelengths as much as possible. 800 gig wavelengths can go a certain distance, but our kind of really target is, well, how can you do 400 gig wavelengths that will carry a single 400 gig client interface as much as possible around our customers' networks. And that's you can see, by the time we head into next year, into 22, we're expecting 400 gig E to be more prevalent than 100 gig E. And a part of that is, we also have to take major consideration the kind of, the higher capacity that we can do, but also the greener part of it as well. It's more green and it uses less footprint in the data centers. So you can see I've just looked at kind of across three different generations of kind of what we would call coherent technology around the modems. This is an example to deliver 6.4 terabits of capacity, across say a 1500 kilometer link. Back when it was a Gen 3, you could see how many these are kind of data center interconnect boxes that Sienna would supply. So you can see the different sizes of how it's increased, or sorry, how it's decreased over the different generations of technology. But what does that actually work out in numbers? Well, from a footprint perspective, we're delivering 87.5% of decrease over that technology. So that's, if you imagine into a large data center, that's the kind of decreases we're seeing over these kind of different levels of generations of technology. For the fiber capacity, which is a real main thing for all the major service providers, is, we're also increasing the fiber capacity up to 75%. As you can see, we're now being able to do 6.8 terabits of capacity inside a set of fibers. That's running at 400 gig. just as these examples, that's 400 gig long haul, but we can do, as I say, up to 800 gig on not so long haul spans. And then if you look at the relative watts per bit, again, we're seeing an 80% reduction. All these factors are massively important for our service provider customers and ourselves as a company that's committed to green technology. So where are we moving forward? Looking at the different levels of coherent technology. Really, it's come down to, and we're in a bit of an inflection point at the moment, around into two different areas, that really are focusing across all kind of types of service provider, or cable operators or global content providers. First of all, you have kind of the high performance optics that they would like, they're driving that highest cost per bit or lowest cost per bit, maximizing their any kind of, from a subsea perspective, they have laid those cables under the sea, massively expensive, and they really want to get as much as they can return for that. So how much maximizing that spectral efficiency on those subsea cables is massively important. Tunable, all these solutions that we provide, are tunable. So you go and have a look at your optic fibers within inside the ground, and then you really depend, you can tune your optics to make sure you get the maximum efficiency. But also they have to work across a kind of flexible ROADM infrastructure or a flexible optical infrastructure that sits below it as well. Now, the second area is really looking at footprint optimized solutions. And this is key for this, what we're talking around this audience, that kind of really small form factor to being able to aggregate those 10 gig or 25 gig into 100 gig wavelengths. And that's, both for the cable operators and the service providers, really to do that, get that small form factor. But also another couple of key components there are really around the extended temperature of these coherent optics, so they can go in street cabs for street cabinets, for example, and also the kind of lowest first cost. And then look at it as how you can do as a kind of pay-as-you-go mechanism of this kind of low first-in cost. But also, the global content providers are really looking for that 400 gig E interconnect between their data centers. Super high density and low power, a single span, very simple to deploy. So then really looking, how do you, these two areas, how do you really drive, the coherent solutions and finding the right partner to deliver it for you? It's really interesting if we look at, this is a graph here on the left-hand side about how quickly the technology has been adopted. 40 gig technology took to ship. I don't know if you can see it, but this is a graph about how long it took to ship 5,000 units. For 40 gig, it took 4.5 years. Now for the 400 gig units, it only took 3/4 of a year. So you can just see, I think I've said it before, the massive explosion in bandwidth that's required in the adoption in these technologies. So it's even more critical that you make sure that you get the right technologies out and the right partner to deliver it. To deliver this coherent or the DSP, what the network service providers are looking for, maximum efficiencies in within the network, the lowest power and cost per bit, and openness and choice. All these kind of really are key around making sure your partner has, the vertical integration. What does that mean? What does a vertical integration means? Some of these coherent technologies have different parts of the chip, the DSP, the front end, the optical electronics, making sure that's all in-house and you're not kind of margin stacking from everywhere else. Not only are you also not waiting on somebody else to develop something, you really want to be owning your own destiny as much as possible when you're developing some of this coherent technology, really from our perspective and our customers' perspective, just so they can get it into the network as quickly as possible and get the benefits. But also, openness and choice is a massive. So, we're also looking at how we interop with third parties to make sure, it gives our customer choice as much as choice as possible. But also you need to make sure that you have the right financial strength and R&D budgets behind that to make sure you can maximize the acceleration of the development of these type of coherent technology. So this is a similar slide, I think, on a similar picture on the kind of left-hand side. But this is really now, and kind of sticking to my car themes a little bit. You know, the two different areas where we're going now for development. First of all, in the top, it's really around the the 200 gig to 800 gig performance optimized. You know, really getting the maximum amount out of your fiber with the lowest number of coherent modems that you would need. You know, I equate this to a Land Rover Discovery. You can fit lots in it, and it can travel a very long distance, and that's really on a motorway, and that's really what they're designed for. Then the other option is, what we talked about is really around this footprint optimized solution, which can deliver you 100 to 400 gig. But these units, to deliver 400 gig can fit in the palm of your hand, which is, amazing from the 22 years of, time I've been in the telecoms industry that we can now do that. But again, that's really optimized for, high density, low power and a very compact footprint. Similar to a smart car, let's say, it's not, it delivers a certain amount of capacity and it's very good around the kind of metro areas. And these are the kind of, these are the two areas where this technology is now diversified into, the performance optimized and the footprint optimized solutions. So if we look at the kind of performance optimized solutions first, these are the kind of areas that where we see it. Two of these really tie in with each other. The cable access and the 4 and 5G access. This is where where the increasing amount of fiber within inside your network also aligns exactly with the increased massive amount of additional bandwidth that's required to backhaul the capacity, but also to meet those kind of small footprint and the extended temperature ranges that you might need within inside those environments and within inside those applications, but also really keeping the real estate cost down to a minimum when you have so many of these network edge sites as well. Then to to realize the single span DCR and the 400 gig ZR, new design techniques have been employed to for the coherent digital signal processing and the optoelectronic devices to achieve that kind of low power and space areas needed to implement 400 gig coherent transmission. And that's going to be delivered in a kind of QSFP-DD or OSFP kind of form factor. So then, how does that actually look, or how does that where do these different types of form factors play into? You can see single span DCI. That's really going to be predominantly around the QSFP-DD area and OSFP. Again, you wouldn't believe the size of them; they're really small. Then moving along, we're moving into the more access and then into the multi-span metro. With the access, we're still expecting the QSFP to play a role there, and that's kind of a 100 gig to 200 gig, more optimal around power and density. But then also, the 100 gig to 200 QSF or CFP2 DCO, that's really going to be around the kind of hardened with a hardened option and kind of built in EDFA or the amplifier as well into it. And then into the kind of multi-span metro, where we're looking at the kind of highest performance and integration more with the kind of underlying photonic layer as well, to get that 100 gig to 400 gig metro performance that you're really looking for. Now, around the other side of the coherent modem is the performance optimized architect applications. Really, this is the main goal here is really to drive the highest wavelength you possibly can to get the best spectral efficiency. Looking at the single span DCI, you're talking about 800 gigs per wave here, where you can fit 8 to 400 gig interfaces into per end. Really, that's all its main focus is. It's very simplistic architecture, point to point, and just driving the highest capacity possible, really used for that kind of GCN or global content providers. Then the next one is the kind of multi-span metro and long haul applications. Here's really, again, you're looking, from the different generations of modem technology, how you can really drive up that, get that 100% increase in wavelength per capacity, but also driving out any kind of regeneration points within inside your network as much as possible, and get that highest data rate with the fewest wavelengths. Means less turn up time from a deployment perspective. And as I say at the side here, it delivers you more than 30% of the kind of higher spectral efficiency. And then the last area is really around the submarine area. If you can go across the Atlantic Ocean with a 400 gig E signal, that's exactly what we want to achieve, getting the massive amount of spectral efficiency out of those submarine cables to maximizing the return on cable investment. So I think that's so. I mean, that was really what I really wanted to cover. So in summary, performance and speed drive down the transport costs with the industry's kind of first 800 gig solution. That 800 gig solution really gives you 50% more capacity per wave, 20% better spectral efficiency. It all depends on what your network is like, but that's the kind of analysis and what we have seen. Performance and speed again around the elegant network evolution, to go into those 400 gig network interfaces on the routers, at any distance across, pan-European, across the UK. That's what we're expecting to see, and that's what we try to deliver for our end customers. And then the kind of around the footprint, extend the scale and ease of deployment and the benefits of coherent technology then into the new kind of applications and the access and metro, and along with the power savings and that gives you. And then the key part of it, making sure you have a vendor that has got all those kind of vertical integrations and systems expertise that we have to be able to deliver the best coherent technology. So just my final slide is really, as I said, back to the kind of making sure that your networks are able to adapt and evolve to meet the kind of long-term changes that we're seeing in the massive amount of capacity that we need. Closer to bring that, the different latency requirements for the different applications, moving that compute closer to the edge. Smarter, we're looking at that kind of self-healing, self-optimizing, self-configuration networks to be able to turn up and quickly provision services as quickly as possible and fix the network as quickly as possible as well. And hopefully, as you've seen, using coherent optics, that's in the access and metro back into the core, really gives you the faster methodology to deliver more bandwidth. So I think thank you very much, everybody, for your time today. And I think James will be heading over to some questions.
We will indeed. Thank you very much. Really interesting, and yeah, definitely a whole new perspective on some of the stuff that goes into from a backhaul point of view. I've had a few questions. The good news is for you, Craig, not as many or not as tricky, hopefully, as some of the ones that Mark fielded before.
Yeah. Okay.
So you can sit back and I will just ask before I go into the questions that have kind of been submitted as we go through. And once again, that kind of asks to the audience, obviously if you want to put your hand up and ask your question directly, now's your opportunity. I'll keep an eye on that. All you need to do is raise your hand and we'll kind of unmute and come to you and let you ask your kind of question direct. So I'll give it a moment to see if anyone has anything burning that they wish to ask. If not, I'll have a few that I'll run through kind of post that. So don't be shy, everyone. Oh, I don't see any hands. Right, I'll fire the first question at you and we'll see if anyone wants to jump in, kind of post that.
Yeah.
So first one to run through. So how do you manage to keep the universal aggregation point at the edge of the network fully resilient? Is there a customer experience risk by having all the eggs in one basket?
Yeah, I saw that actually. So I think that came in from Steve there in the chat. Yeah, I mean, obviously that's a very simplistic diagram that I've represented it. But you can use various different technologies. Either as I said, that network universal aggregation point will, support optical and most likely IP routing as well. So you can have standard IP routing protocols and protection mechanisms out at that point of the network. Also, you could look at how you would build diversification. How did a lot of the networks built, into horseshoes that, have an east and west point optical fiber out of them that then goes back to maybe the metro. So it's really about how your network is architected and what layer you maybe want to do kind of the resilience or protection with inside your network. They're all pretty much going back to some similar points. So, that's the kind of, really delve down into the architecture. Are you going to get the protection from a, more east and west fiber diversity, or are you going to do it with protection at layer 3 protection instead? I think that's, so definitely, customers are super keen about resilience, and that will be definitely built into, and the devices all out at that point in the network of dual redundancy control processors, dual power supplies, dual everything else, just to make sure that, you've got the highest mean time between failures as well.
Cool, awesome. So next one, obviously around the kind of orchestration, automation side of things. So APIs give some great benefits, but they also give 1 point for hacking.
Right.
And obviously keeping APIs up to date becomes a necessity for all. Thoughts on that?
Sorry, James, you broke up a little bit there. You just repeat that question?
Sorry, yeah, it flicked up. Right, let me go through that again. So APIs give some benefits, but also they give 1 point for hacking. And obviously the onus then on keeping APIs up to date becomes a necessity for all parties in the complete network. So I suppose it's any thoughts on that?
No. I wouldn't say security would be my strongest point, but yeah, you're 100% agree. The APIs do you have to be kept up to date, but also, I mean, it's APIs, but where are we looking to drive an API between? We're looking to drive an API northbound out of a device or from the software into a southbound into a northbound, area controller or SDN controller, and then finally even further high up into the BSS or OSS stack. So this is all within inside, your environment or the service provider's environment. So it's not so much of a looking at the APIs. Maybe I would say it's as equally to make sure you look at the whole security architecture around your network. Also, I mean, there are, methods as well of locking down devices, that are maybe out at the access or edge of a part of your network as well. ACL lists and port lockdowns and intrusive tests. A lot of service providers in different parts of Europe, have to go through around all that kind of security testing. So, there are definitely ways to make sure that you keep your network secure. But I would say, APIs is one area, but it's also around the whole kind of your network architecture around security.
Awesome, thank you. Another one's around power. So this kind of question was raised actually from a DOCSIS point of view, and kind of similar now, but from a fiber perspective. You've probably seen it in the chat as well. So how has the kind of power consumption, watts per gigabit, changed with the increase in speeds? Both from a data center or an edge network?
Yeah, I thought I'd wonder if I can still, am I still sharing my slides? Yes, I am. Give me a second.
Yeah.
I thought I did.
You had the graph one a few back, didn't you?
Yeah. If you look,
so it may just be a summary then.
Yeah, no. So if you look at this diagram, can you see my mouse?
Yep.
So if you look at this diagram, this is over what we would see, and it's massively important, as I say, for our service providers and us as a company as well, that we meet certain green requirements. But as you can see, our watts per bit for that solution has decreased by 80%. Over the last, this only goes back to generation, like our third generation of Coherent technology. You could go back further behind that, but you would still see the kind of decreases that we're seeing. And this is really, how is that achieved? If you imagine, one of these devices on the left hand side was doing a certain amount of capacity, but now you've got a very similar device that's maybe doing 4 or 5 times or 6 times the capacity, but it's not consuming. It'll maybe consume a little bit, a little bit more power, but it's not consuming any, 6 times the power capacity. So that's where we're really seeing the benefits. Similar kind of types of hardware that are just driving a ton more capacity than they used to be. So that's where I think hopefully that answered the question, where we're seeing that kind of 80% decrease in watts per bit usage. For this was a kind of an example using 6.4 terabits using our data center interconnect product, let's call it.
Awesome, thank you. And I think that is you done with questions. Nothing else has come in the meantime. So yeah, you've obviously answered everything via your presentation.
Oh, maybe I confuse people. People aren't used to talking around this kind of part of the network, but yeah, hopefully they find it interesting.
No, it was really interesting and loads of different perspectives to kind of consider it through. So thank you very much. And yeah, that was awesome.
Thank you.
So on from the next steps then. We're going to take a very quick comfort break again. Conscious we're getting to the ends of working days. So we're going to take another 10 minutes shortly, once again, just for grab a quick drink, if you want to check emails, whatever you want to do. But we'll take a quick 10-minute break. And when we return, slightly different format for the next bit. I'll be welcoming kind of Yvette, and rather than a presentation, it's very much more a chat, fireside chat type scenario. Well, one thing I did just want to say before we go for that break, we really want your participation in this next bit. I've come up with some questions selfishly from some of the bits that I'd love to find out, which obviously I'll be running through with Yvette. But likewise, this is an opportunity as well for you to kind of ask your questions. No hard and fast theme. We'd love to cover bits like trending technologies, the whole startup, the whole innovation type idea. And those pieces around kind of career development and next steps and stuff. But if you have anything you wish to raise, obviously you've got 10 minutes or so to have a think through that. When we get back, I'll kick things off. And, by all means, we want to be welcoming your questions as we go through it. So that's all for me for 10 minutes. I'll welcome you back just after 22, if that's all right. And I think, Tony, you can put a little flash thing back up on screen if that's all right. But yeah, I'll catch you all in a moment.